Hi FOSDEM 2022 online watchers. Today we speak about Oniro blueprints. First we will introduce ourselves, then we will explain about the Oniro project and how we calling blueprints inside this project. Then my colleague will show you some demos and we will share hints how to get started with Oniro and how to create your own demos for next FOSDEM edition, right? And then we wrap it up and answer some questions. So who are we? Obviously we are part of the Eclipse Oniro project, and also we are members of Huawei Open Source Technology Center, which is an open source team decentralized worldwide, mostly in Europe, but not only. Oniro is one of our main projects, but we are also doing upstream development in a related project when there is a need for. And myself, I'm coming from technical background. Maybe you saw me at a previous edition of FOSDEM, and I play a senior technical marketing role inside this team. And my guest, Andrei Gherzan, is our principal solution architect inside the team. And I want to also give credit to everyone that's been involved into Oniro Blueprint, because it's a teamwork, and we've been working with people from OSTC, but also partners of Eclipse Oniro project. What is the Oniro project? It's an open source distributed operating system for IoT devices. What do I mean by IoT device? Well, depends. It can be very, very wide, from very small device where there is very few resources to bigger one. So that's the challenge of Oniro. How can we make some systems that can work with such kind of different devices? And how do we do it? Well, we want to defragment the development for embedded system. We want to break technology silos. This can be a feature of the system, but it can be also the ecosystem for the software development. It can be very difficult to move from one platform to another. There is a lot of dependencies that are specific to the platform, and it's making the developer life quite difficult. So we can simplify this by unifying the tools. This means how do you build a software, and there is, even if you are working on different range of devices, you are writing code, and there is a lot of common policies that can be applied different depending on the context. So that's the challenge of the Oniro project. And now let me explain about who is hosting the Oniro project. Before I answer this very important question, let me share you some background story. Before the project was even called Oniro, Huawei Open Source Technology Center, OSTC, was working on an operating system for IoT. Yeah, the very same one that's been presented at FOSDEM 2021. This project was open source and open development, so the new members joined in, and then it was quite logical to have a bigger structure to take care of the future of the project. So at the end of year 2021, the project has been relocated from OSTC to an Eclipse Foundation. Now it's a top-level project under Eclipse Open Governance. So this means that the decision inside the project is made by a working group. Huawei OSTC is one member of this group, but there are also others. And it's quite interesting to have this neutral approach if you want to reach some IoT interoperability and to have more flexible operating system. The most diversity we have in the decision is making the project more open and more suitable for its vision. At the same time, this project has been designed to be OpenHarmony compatible. OpenHarmony is also another operating system which is open source, of course, and the project is hosted by Open Atom Foundation, which is China based. And here we are in a situation we have two different foundations. We are working together for a global open source project. That's quite challenging if you take into account all the specificities on China, Europe, United States, and so on. Each have a different approach, different cultural, different technical background, different way to do open source, and the way software is used also depending on the territory. Regulation can differ from one country to another, so we have to adapt also specificities for different places, but some things, some common ground can be reused from different contexts. So that's the challenge of Oniro, and it's open to anyone, so you can feel free to join us. What's inside the Oniro platform? Well, it's a standard software base for making product and solution. This means we are not reinventing everything from scratch. We are based on mature open source project. If they're not yet mature enough, we'll try to improve them to achieve the required quality, and we try to identify existing components that can be available in the community and trying to fill the gap if there is some feature missing, and then we are integrating back into Oniro. That's quite a common approach in open source software. Let's explain with an example. Because we want to support a different range of IoT devices, we are using Linux on big devices that cannot really work well on smaller ones. So instead of making fit Linux into smaller device, we try to identify a RTOS that is more relevant, and then we are integrating into Oniro. So today we are working with Linux on Zephyr, and also we are ongoing work with LightOS. Both will not run at the same time, but they will try to be used depending on the context, of course. Anyway, even if we are working on different devices, there is a lot of things that can be factorized. For instance, the way to build firmware. We can reuse a build system from OpenEmbedded and Yocto, which is based on BitBake. That's a tool maybe you already know, and that can be reused for also supporting other operating systems. That's something convenient. If working well, there is no need to not use it. That's what we try to change into the software industry. So in the end, Oniro becomes a point of convergence, because each feature can coming from a microcontroller, for instance, or for a CPU. But if the code is generic enough, it can be shared among different profile of device. So in the end, we have Oniro becoming like a point of convergence where the code can be shared into a common place that can be reused in different contexts. So what does Oniro provide to its users? Of course, even if we share this open source code base, without this community, it can be almost useless. So to prevent this, we defined and implemented the best practice we learned in the software industry for years. We are coming from open source background, so we set up open development model. This means the code is reviewed by the community, and also we are setting up a GitLab flow using for continuous integration, different kind of check, and we are testing on supported devices. We are checking for the quality of code, but not only that, we are also taking care about the legal approach. This means that we make sure that the code can be shipped into products. That's sooner problems are detected, better it is, because that's something you cannot replace at the last minute. If there is some patent infringement or something you cannot distribute in some territory, sooner problems are identified, better it is. Talking about scanning, of course, we are scanning for security and also trying to apply latest vulnerabilities known in dependencies and so on. That's a part of our security team duty. And we have also strong interest into privacy. Let me explain a little bit because that's something maybe not obvious. For instance, Oniro is mostly targeting the European markets. This means we need to comply the GDPR regulation. Maybe you all know about GDPR, but if you look at Article 25, maybe you don't know about it. It's quite interesting for open source project, because if this article recommends the systems to be privacy by design and by default. So we can take this into account at the specification level and try to make sure if something can be done in a privacy friendly way, it will be done this way, and we will not put every data in a cloud and then trying to secure it. We can do it with different approach and trying to make data closer to the user by deploying some different architecture, more based on the edge. That's an example. And also we are taking care about security, so to ensure that software is updated we are providing mechanism for doing over-the-air update. That's one of Oniro services among others. And that was the operating system, but that's not enough. We have also Blueprint's complementary projects. Let me explain this. What are we calling blueprints inside Oniro project? Blueprints are not part of the operating system. It's more a bigger picture. It's more like a minimum viable product built on Oniro project. Of course, it's all open source, like the operating system, from design to implementation, and it's more focused on use cases. So it's like a near finished integration of a product. So we are using this to, of course, validate a specific feature, validate the whole software stack, this means Oniro OS, and also a specific use case. So those projects are co-living the main project, and we are doing the testing on blueprints at the same time on the OS, and it's something that can be used for validation, for demonstration, and also to get into Oniro, because you have a basic use case you can get started from. Maintenance is something important, and we want to make it the most easy to reproduce. This way anyone can adopt a blueprint to try to decline into something different, or to try just to get inspiration from it. Let me clarify and explain about the Oniro blueprints logic. Everything starts with an idea, so you want to create a product that satisfies a specific use case. Just try to think about the minimal use case you want to address, and see if Oniro system can provide everything you need to create this product. Maybe not yet, so maybe you need a specific feature. This feature can be specific to your business, so you need to specify and implement into your blueprint, and that's part of the blueprint development process. But maybe this feature can be shared at the platform level. This means it can be also useful for other blueprints or user use case, and it can be now shared inside a specific service layer of Oniro. And then Oniro becomes stronger and more sophisticated to create more advanced product and address more sophisticated use cases. So once you have implemented your blueprint, which is illustrating a specific use case, you can focus on the value you want to build on top of this base. So you maybe take care more about the customization, about extra services and so on, which can be part of your business and not part of the shared Oniro project. So to get started, maybe you can have a look about some product foundation we shared today in this Jasmine release. We addressed some very specific use case. One is a vending machine, which is showing how to interact with an IoT device using a touchscreen. We have also another touchscreen called the Keypad, which is running on the microcontroller, which is a slightly more generic approach. And my colleague Andrei will show you all those blueprints in action. But what you need to remember is that you can define a use case, and you can try to implement it using Oniro, make a blueprint, and then you have almost the base to create your product and focus on the specific value of your business. And thank you for listening on this part.
Hi guys, I'm Andrei. Thank you, Phil, for the first part of the presentation. Now, Phil provided us with an overview of the project, of Oniro project. He also gave us an overview of the structure and different elements as part of its ecosystem. But he also mentioned ways of how we reach our partners and users' business logics. And some of those ways are the blueprints. In this context, he mentioned a couple of use cases. He mentioned a vending machine use case. He mentioned a keypad use case, to name a few. Now, all these use cases have a corresponding implementation in our build infrastructure. It was mentioned before that we are using Yocto, Open Embedded, BitBake as our build system. So you'll find layers and recipes and metadata that implements these blueprints. Great. So in the next slides, I'm going to go through a couple of these blueprints, give you an overview, and also through some videos or pictures, show them in action. So the first one is the vending machine blueprint. Now the use case is quite trivial, right? We've all been to a place where we wanted a beverage, so we've seen a vending machine and we followed the vending machine process to get one. In Oniro, we have implemented a vending machine blueprint that takes advantage of two applications, a UI and a control application that act as a server and a client. These applications are running on a kernel, on a Linux-based kernel that is on a Seco x86 based board. The UI application is done using the LVGL toolkit. Now, if you're not familiar with the LVGL toolkit, I can tell you that this was initially done for MCUs, later on ported on Linux, namely on Wayland. We have upstreamed the recipe in Open Embedded, so you will be able to find that support in the upstream ecosystem as well. The communication between the application is done through WebSockets. The API used, you will find that documented as part of our Oniro documentation, is inspired by WebThings. So the UI application is driving a HDMI display and the control application is driving a 5x5 LED matrix, simulates different operations on the vending machine. So you can select an item on a grid of items on the display, and the associated LED on the matrix is going to light up. Red is for selection and other colors for different other options. You can select multiple items, you can deselect multiple items, and once you are fine with a selection, you can go ahead and click buy. This will turn the LEDs blue, showing that they are undergoing a delivery process, and the UI is going to wait for that process to end. And once that happens, a completion message is going to be shown on the display, and that will reset the process. Great, so this is the vending machine blueprint. Now, if you want to take the UI application onto an MCU, onto a microcontroller, you could take advantage of the Oniro Keypad Blueprint. Now, in theory, you could rebase the UI application that we just described on the vending machine on top of Zephyr Kernel. The problem is that the Zephyr Kernel LVGL version is different than the one supported on Linux, and the APIs are incompatible. So we wrote a different application that communicates over BLE, over Bluetooth Low Energy. Via a bridge or adapter, you could control further on the control application on the blueprint that we just described, the vending machine one. In terms of experience, the situation stays fairly similar. You have a grid of items that you can select, deselect, and the selection events will trigger different actions. Now, this is the early stage of development, and we want to take this to a level where it's completely use case agnostic. So you could reuse it on any application that you are interested in. And you could do that by reusing a defined API that lets you describe, for example, the appearance of the elements on the screen, their shape, their form, being a number or an icon, and so on and so forth. And also defining the actions that each touchscreen event trigger. And that is the Keypad Blueprint. The next blueprint is the door lock. The use case is as follows. You have a door lock and you want to control opening and closing the door lock based on the keypad. Also functionality like setting a pin, resetting a pin is included. Now, the application we wrote is based on Zephyr, so you will be able to run Zephyr on a supported target and run the application that satisfies these requirements. Now, this is just a sneak peek at this blueprint. There is a full talk by Barrow later on, so keep an eye on that for full details. And in order to show you the blueprint in action, I'm going to play a video that Bero did a couple of weeks ago.
When we first power it up, the LED on the Arduino board starts flashing, which means it's ready to learn the pin that will be used in the future to undock. Obviously that pin is stored in non-volatile memory, so even if a burglar manages to reboot the system, that doesn't help him. Let's pick a pin that is really secure that nobody could possibly guess, like 1, 2, 3, 4. Since the system doesn't limit us in the length of the pin, we have to tell it we are done by pressing those two keys at the same time. Now the LED has stopped flashing, that means it's now operating in normal mode, waiting for someone to enter the correct pin. So if we enter something that's not the correct pin, nothing will happen. And if we enter the correct pin, 1, 2, 3, 4, our lock opens, we can open the door, and then it is automatically relocked. Of course, we can also change the pin. To do that, we enter the right pin to make sure it knows where we are allowed to do it, and we press our two special keys again. Now the LED starts blinking again, and we are ready to enter the new pin. One special feature is that the pin can include multiple digits pressed at the same time. So let's still use 1, 2, 3, 4, but 2 and 3 pressed at the same time. 1, 2, 3, 4, and we are done. The LED stops flashing, and our old code of 1, 2, 3, 4 just won't work anymore. But 1, 2 and 3, 4 opens our lock.
Thank you, Bero. And that was the door lock shown in action. Hope you enjoyed it. The last blueprint that I'm going to touch in this presentation is the IoT Gateway Blueprint. Now the use case here is a pain that we all felt. Every time we get into a new ecosystem of devices, we need yet another gateway, yet another supported protocol, yet another box that we need to chuck into our data rack. The IoT Gateway tries to solve that by implementing a blueprint that is scalable, not at the level of devices, but at the level of protocols. You can include multiple protocols on the same device, so you can support multiple infrastructures of devices in your home. The implementation we have at hand here is for Thread protocol, which specifies a low power IoT mesh network. From its features, I'm going to mention a self-healing, low latency, IPv6 connectivity without a single point of failure, to name a few. In this implementation, you can see a border router implementation on Linux that is running on a Raspberry Pi 4 board, and a Zephyr based mesh node that is running on an Arduino Nano 33 BLE Sense. You can register the node onto the network, taking advantage of the Thread application. This one is running on an Andrei device, and it registered the node onto the network. All these blueprints are going to be further detailed in separate presentations. You can find more details on that on our virtual stand, so keep an eye on that. Awesome. So these are some of the blueprints Oniro project provides. So the next natural question is, how do I build such an environment? How do I build a blueprint on my own system? The main point of reference is our documentation, and that would be docs.oniroproject.org. That includes information about blueprints, about architecture decisions, about supported hardware, about API specification, to name a few. It also includes information about how to download the sources. We use repo manifests so you can download the entire environment in one go. We also provide a Yocto layer specific for the blueprints that includes the entire metadata needed for building the blueprints. Once you have that, you can build any blueprints that the project supports. You can also take inspiration from it and create your own blueprint. It's as simple as defining a distro configuration that is specific to your use case, along to an image that defines all the components that are needed by your application. Once you have that, you can build your blueprint.
Thanks, Andrei, for showcasing current Oniro blueprints. It's time for summary now, and if you need to remember something, is that Oniro is an operating system for IoT devices. Its approach is a bit different because we want to support a different range of devices, and to do this we are supporting different kernels. So we are using Linux for big devices, and we are using RTOS for smaller ones, like Zephyr and or LightOS. The core OS comes along with blueprints projects that are more focused on the final use cases. They want to satisfy a business requirement, and if there is a specific feature that can be shared among different use cases, of course it can be relevant to propose it to land inside the core OS like a service. Those blueprint projects are easy to reproduce from scratch. You can try existing one or try to get inspiration from, and then you have a base to create a product which is Oniro based in the end. If you want to learn more about Oniro itself, its internal, please bookmark online FOSDEM stand. There you find a related discussion about Oniro. There is also some demonstration, and of course there is a chat room when you can try to reach us and try to ask more about Oniro internals, and I can also share some resource there about Oniro and related projects. And if there is some question, we can handle some of them just now after this presentation. And thanks for watching, and it was a pleasure to be at FOSDEM again. And thanks again, and see you at the online stand.
That's the Q&A session. So I haven't seen many questions asked in the chat, but I do have a few. In your talk, you mentioned that there are some gaps that Oniro intends to fill. So I was kind of interested if you could give some examples of gaps that you have identified at Oniro and that you are working on filling.
Sure. So first, all the gaps are not yet identified. This is something that's been discussed by the working group. So that's something we decide for the next release. We have found some gap we can explain that maybe we want to have something, some component can be flexible to run on different range of devices, like for instance the UI toolkit, we were talking about this earlier today. That's something we can be portable between different contexts.